Hey there. Today what we're going to be doing is finding the molecular mass of butane. The butane is the hydrocarbon that is used in lighters. Okay? And when you look at a lighter, this one's clear, you see there's actually a liquid inside. Butane under pressure, not very much pressure, will liquefy. But there's a little valve on there where I can expose the butane to atmospheric pressure, where then it becomes gas. So when we burn a lighter, it's actually turning that liquid into a gas. The gas is what's actually burning. So let's get started on determining the molar mass of this mystery gas, butane. The first thing we're going to do, and it seems a little crazy, is I'm going to place the lighter underwater. I'm going to get it all soggy. The next step is to dry the lighter. And you're saying to yourself, Mr. Lockery has finally lost it. He got it wet, now he's drying it. As a matter of fact, I'm going to take it over to the hairdryer for a second and dry it even more. All right, nice dry lighter. Now, do you think after submerging it that some water got trapped in some of the little nooks and crannies that are in here that I really can't get to, and I couldn't even get them out with the hairdryer? Might this have a little water trapped in it? That becomes important. So, my first measurement. The mass of this lighter assembly is 10.846 grams. Let's go ahead and write that down in our data. All right, great. Now, what we're going to do at this point is follow kind of the same procedure we used last with my gas collecting tube. So what we're going to do is I'm going to fill the gas collecting tube all the way to the top with water. Don't have to worry about hydrochloric acid today, so I'm goggleless. Tap some of these little bubbles out. I don't want any air trapped in here. I got a little bit. Great. And then I'm going to do the same thing I did last time. Use that big chubby finger of mine, plug up the top, and invert it into my overflow can full of water, so there's absolutely no air trapped in there. So let me explain to you what we're going to do in this next procedure. So I have the gas collecting tube completely full of water underneath other water. I'm going to take the lighter assembly and I'm going to place it upright in the gas collecting tube. I'm sorry, the overflow can. And the gas collecting tube is going to press right on the little valve opening that you use when you hold a lighter to keep it open. The valve sitting right here is going to release the butane gas when I do that. So I'm going to push the assembly down, depress this lever, and the butane gas will start bubbling out, displacing the water out of the tube. So I'm going to push the water down. At some point, I'm just going to be able to measure that volume of butane that I collected. So let me show you how this looks. Let's go ahead and do it. All right, so I'm going to take my lighter and I'm going to stand it up on the side. I'm just going to kind of slide it down to the bottom of this tube. Then I'm going to carefully move the gas collecting tube over the top so that no air gets trapped in, and push down. There we go. Now you can see all those little bubbles of butane gas flowing up. I'm going to shoot for about 95 to 100 milliliters. All right, so I've stopped collecting the gas at, you can see how this thing's graduated in twos. I want the levels inside and outside to be equal, of course, so the pressure is equilibrated. Looks like it's below that middle line, which is the 93 line. 93.4 milliliters. Yeah, I'll go with that. 93.4 milliliters of butane. Let's go ahead and record that. And of course, we're going to have to convert that to milliliters when we do our calculation. All right, now the next step is going to be dry the lighter again. Now, after I'm done drying the lighter, do you think I have the same amount of water trapped in it as I had before? After all, I couldn't get to it the first time. There's probably some water trapped in there, but I couldn't get to it the first time. Do you think I can get to it the second time? This is kind of what we call experimental conditioning. It's in the same condition now, well, it will be once I dry it, that it was in the beginning. But because there might have been a little bit of water trapped in at the beginning, my first measurement, I want to make sure I have that same situation in the second. So I will come back after it's dry. All right, back from drying. Let's see what the mass is now. 10.641 grams. Let's record that. Now this particular measurement here is not really a measurement, it's a calculation, because I know I started with the mass of 10.846 grams, and then the final mass is 10.641 grams. So obviously I can figure out the mass of butane that was actually evolved from the lighter. I don't think that's going to be too difficult for you to do. 3 other measurements: barometric pressure, temperature, and vapor pressure. So how do we find those? Well, we live in this crazy world where I can just go on to the weatherman's site. He says it's 30.05 inches of mercury today. Also, that arrow says it's rising, meaning that there's actually a little storm system moving out. So weathermen keep track of storms. That means weather's getting better. If the pressure was dropping, I'd be looking for clouds. 30.05 inches is 763 millimeters of mercury. Let's go ahead and record that. 763. Called the barometric pressure. And because I equilibrated the liquid levels inside and outside the tube, we know that was the pressure of the gas inside the tube as well. Sorry, my computer's really lagging, and every time I write. All right, that's supposed to be a 3. You know that. 763. Okay, temperature. Right now in my little place, it's 68 degrees, which makes it 20 degrees Celsius. That makes it easy, doesn't it? We'll probably change that to another unit at some point. Just like our volume, we'll probably have to change that to liters at some point. Okay, the vapor pressure of water at water temperature. The water's been sitting out, so it's the same temperature of the room. There we go. Found it. All right, vapor pressure of water. Again, I just looked up vapor pressure of water table. This came up. At 20 degrees Celsius is 17.5 torr. Millimeters of mercury is sometimes called torr in honor of that guy Torricelli who came up with this whole thing. So let's call it let's call it 18. 17.5, we can round to 18 for sig fig reasons. Yeah, you can substitute torr for millimeters of mercury at any point. So what we're looking for here is the molar mass. Our goal is to find the molar mass of the butane. What units is molar mass in? Carbon is 12, carbon dioxide is 44. What units do we have? Well, you guys know this. It's grams of substance per mole. It's a ratio, grams per mole. Now, how do we find grams? Ta-da, that's how many grams of butane we collected. How many moles did we collect? Well, there's probably a gas law in there to allow you to determine moles. If I take my grams divided by my mole value, I'll have my molar mass. And that's all there is to it. I think we are done with this lab. So get to the calculations. I will see you soon. Thanks for stopping by.